Hi guys, welcome to Exponents Day 2. Just want to commend some of you. I see your work on Alex. You guys are doing a great job. I even noticed that some of you are done with all your topics already. Remember, you have the 7 due by this Friday. If you guys ever have any questions about the work, please email me. I will either we can do a Google Hangout or I can answer your question on a YouTube video too, okay? So let me know. If you guys have any late work, I see some of you finished your 7 topics. So if you have any late work or any late topics to do, please do those. And then just send me an email and say, hey, can you update my grade? If your late work is any like assignment, paper assignment, let's wait till we get back together and then you can send that to me, okay? So I told you guys about this yesterday, 7 topics due this Friday, okay? We also have a quiz this Friday that's gonna be on Alex. And many of you have already finished the knowledge check, so thank you so much, okay? Make sure you guys stay on track. So yesterday, we talked about 2 rules, the product rule and the power rule. If you forgot these, make sure you go back and review the yesterday's video. So the product rule, remember, product has to do with multiplying. So we're multiplying 2 exponential powers, right, with like bases, 5 and 5. If they don't have the same base, then you cannot multiply them. So this is simply, it's 5n plus m, okay? So here you're gonna be adding. You're gonna be adding the powers, like that. Now, the power rule is when you have 1 power and then closing parentheses and you have another power on the outside of the parentheses, okay? So what you're gonna do here is you're gonna multiply. You have 5 to the nth power times the mth power, okay? So you're multiplying here. Multiply. Now the quotient rule is what we're gonna do today, okay? Quotient has to do with division. That fraction represents division. So when you divide, you're gonna be actually subtracting. And this is what we're gonna do today. When you're subtracting it, it's simply gonna be the 5m minus n. Okay, so these are the 3 rules, the only 3 rules that we have for this week for exponents. So let's review a little bit from yesterday. So if you just cover this one, this was actually a question taken off from Alex. If you just cover this, right, this is, which rule is this? Is this the power, product, or the quotient rule? This is actually the power rule, okay, because you have a power outside of a power. So you're gonna apply this power here, here, and here, okay? So let's not even worry about that one yet. So remember, this is a 1 right here. So I'll show you the long version. It's 2 cubed x to the 1 times 3, and then z to the 3 times 3. You guys see that? So then we should have 2 cubed is 2 times 2 times 2 is 8. X to the 1 times 3 is 3, and then 3 times 3 is 9, so z to the 9th power. So that's 1, and let's do the same thing here. Let's apply the power here, here, here. Now remember, there's no number right here, but there's actually 1, okay? So 1 squared times x to the 4 times 2, y to the 2 times 2, and the z to the 3 times 2. So 1 squared is just 1. X to the 8th power, y to the 4th power. Remember, we're multiplying. And then z to the 6th power. Okay. Now we can start multiplying the like bases. But this is now going to be the product rule. It's this one right here. So we're multiplying them. It's going to be n plus m. You're adding the exponents. So 8 times 1 is still 8. X to the 3rd power, x to the 8th power, you're going to add those to be x to the 11th. Now the y, there's no y on this side, so it's just going to be y to the 4th. And how about the z? Z to the 9th power and 6th power, that would give us z to the 15th power. Is there anything else we can combine here? Can we combine anything else? Nope. So that's our answer. Oops, shouldn't lick your fingers. okay? Don't lick your fingers. You're not supposed to do that right now. All right, so the quotient rule, what it says right here, you're gonna be subtracting these. And what I want you guys to think of is, think of the phrase, which is more, and then also how much more. Okay, so now which has more, the numerator or the denominator? Okay, obviously you can see that it's the denominator. And how much more does it have? How much more is on the denominator? Well, since you're subtracting, it has 3 more. Okay, and we're not gonna leave this blank up here, and it's not an x, okay? So this is just gonna be 1. Same thing here. You have x to the 7th power, so which has more? Which is more? The numerator. How much more does it have? It has 4 more, like that. And you don't need the 1 right there if you don't want the 1 right there, okay? So let's write this out, what this actually means, okay? What it means is you have 6 ends, 1, 2, 3, 4, 5, 6, and you have 2 ends right here. So there's a magic math, or the magic exponent fairy. What she does is, I'll draw her, okay? She looks like this. Okay. What she does is when she comes and flies down and she takes away anything that's a pair. Right, so that's a pair, so we're gonna eliminate that. That's a pair right there, we're eliminating. But you cannot eliminate these 4 right here because there's no adjacent n in the denominator. So now how many n's do you have? You have n to the 4th power on the top, and you just have a 1 on the denominator, right? Same thing, which is more? The top has more. How much more? Has 4 more. So this will be your answer. Please pause this video anytime. Maybe you want to try this one on your own, pause it, and then you can come back and do it on your own. All right. So for this one here, I'm gonna go ahead and write it out again. So this 4, right, if we factor that, that's actually gonna be 2 times 2. This 6 is gonna be 2 times 3. And then we have an n and an n. And how many n's do we have right here? We have 1. So this would be n right here. We have a y and a y and a y, 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 y. Okay. So let's see what can we eliminate. What can the math fairy take? So the math fairy can eliminate these. Can't eliminate the 2 and 3, so they'll stay. Eliminate a pair of n's, eliminate a pair of y's, and a pair of y's right there. So let's see what's left in our answer. So the numerator, we have a 2. Denominator, we have a 3. We have a n in a numerator. And then how many y's do we have? We have y cubed. So that'll be our answer. Okay, good job. Okay, so let's try the quotient rule with negatives now. Notice that right here you have a negative. All right, so that's something new. What happens with this is that when you have a negative, it's actually, you're gonna take this and the whole thing goes down to the denominator. However, when that happens, it's going to turn positive. So now what essentially you have nothing in the numerator. You have 1, and you have x to the 4th power. So this x to the negative 4, what happens, it went to the denominator right here. So you have x to the 4th power, x to the 6th power. Now can you combine these? Can you multiply these using the product rule? Of course you can. So that's just simply going to be x. And do you guys remember, do we add the 4 and the 6, or do we multiply the 4 and the 6? We are going to add them. So we have 1 over x to the 10th power. You guys like my books? Curious George, one of my favorite books ever. All right, so let's try this one right now. I'm going to add a 1 right here because that helps me. So looking at the x's, which has more? The numerator. How much more does it have? Let's see, 4 minus 1 is 3, so x cubed. And then look, oh, we have a negative again. So this negative, y to negative 1 power, has to go to the denominator. So now I have y to the 1st power, and then y to the 5th power. I can combine those to be x cubed, y to the 6th power. So it might be tempting now to simplify the 3 and the 6, but you can't. Why not? Because the x and the y are not like terms. They're not like bases. So there's your answer. All right. We're going to finish up with just one more question. This is the quotient and the power rule combined. In case you forgot what the quotient and the power rule is, let's review again. We did earlier. These are our 3 rules. So we're going to look at the power rule. That's where you have the power outside of a power. And the quotient is the division. All right? So congrats to these people. Periods 4, 5, 6. Period 6, you guys are rocking it. Okay? Keep it up, please. Keep it up. I saw a lot of you finish this week's topics already. Go on to next week's, okay? So last question. Whoa. Look, we have quotient rule inside, and then we have the power rule. So our question we got to ask is, do we apply the power first, or should we simplify inside? And just like PEMDAS, guys, all right, let's do what's inside the parentheses first. I'm just going to write PEMDAS right here. So let's simplify inside. So inside, we have, so now simplify the 4 and the 6, that would be 2 and 3. Okay, right? You're going to divide this by 2, divide this by 2. And now look at the a's. Which has more? How much more? So there are more a's on the denominator. How much more? It has 2 more. Okay, so 1 right there. Now, the b's, there's a negative, so this has to move up to the numerator. So that negative 2 is going to a positive 2. 1 plus 2 is 3. I'm close this off, and I still have the cubed out here. So now we're going to apply the power. We're going to apply the power to the 2, to this power of 3, to that 3, and then to this 2 right here. Power, right? So now 2 cubed, b to the 3 times 3 over 3 cubed, a to the 2 times 3. So that comes out to 8 to the 3rd power 6, and 8, right? So 8 over b to the 9th power. 3 times 3 times 3. 3 cubed is 9, 27. A to the 6th power. So now double check, is there anything we can simplify here? Can we simplify the 8 and 27? By 2, no. By 3, no. The b's and a's are different, so voila. El fin. Okay, again, please let me know if you have any questions. Feel free to subscribe to my YouTube channel.